Hi there. Okay, so today I'm going to briefly talk to you about some other kind of special bonds that happen with ionic bonds. And I'm going to be general about this because this can be, this is kind of like the hardest part of chemistry, but I just want to kind of make sure you know about it and show you how it works and how you can identify it, okay? So don't get too nervous about it. Once we take a look at it, you'll see it's not as bad as it might look at the beginning. Okay, so ionic bonds are between a metal and a non-metal. And I said before that they're between a cation and an anion. Those are the key words you want to look at, okay? So make sure you're on page 12 here. Let me zoom in just a little bit here, okay? Now, some metals, especially transitional metals, can form more than one kind of ion which make different kinds of compounds. Okay, so the transition metals on our periodic table are all the ones from the alkaline earth metals to the staircase. To be fair, it's about there. Okay, so everything in here has the opportunity to make more than one ion. Okay, or have more than one charge. And we can tell this because if we look at Professor Mokur's periodic table and we take a look at different elements like manganese, look, it has 2 charges. Nickel has 1, copper has 2, iron has 2, cobalt has 2, and we never know which one it's going to be, but they can make liquids and compounds that are very different than each other. So the example they give here is iron. Okay, so find iron on your periodic table. Iron has to be in the middle here, transition metal. Here's iron, okay? So what are the 2 charges that iron can make? Well, +2 and +3, okay? Okay, so if we have a charge of +2 for iron and chlorine, which is -1, when we crisscross and combine, we'd have FeCl2. But if we are using iron 3, okay, and we crisscross and combine, we would have FeCl3. Now, by the usual naming ionic compounds, both of the above would be called iron chloride, okay? Iron chloride. Iron, change the IDE for the second one, they're both the same thing. But since these are completely different compounds with completely different properties, it is important to distinguish between them, okay? It's like having 2 twins and calling them by the exact same name. They have different characteristics. They're different people. Just because their genetic makeup is the same, you need to have a different name to call them, okay? So Roman numerals are used to show which ion it is in the compound, and this is called the stock system. Oh, sorry, and you can't even tell me that, okay? So by the usual naming of ionic compounds, both of the above would be called iron chloride. Since these are completely different compounds with completely different properties, it's important to distinguish between them, and we use Roman numerals to show which ion is in the compound, and this is called the stock system. Okay, so FeCl2, we would call it iron, and then in brackets we put Roman numerals 2, chloride. Okay, because the charge for iron that's being used is 2. The charge for the iron here is 3, right? FeCl3, so we put iron 3 chloride. And just using those Roman numerals tells us what is the charge of iron, okay? So this tells you the charge of the cation. Okay, so copper 1 oxide, if we flip this around and do it the other way, copper 1 oxide tells us that the copper we're using the one that has the charge of +1, okay? And if we look at Professor Mokur's periodic table, here's copper, and it has two possible charges, +2 and +1. Okay, so copper +1 with oxygen would be Cu2O, but if we use copper 2 oxide, that means that copper has a charge of +2. So then it would be CuO, okay? And why? Because when you crisscross and combine, you have Cu2O2, but you divide both of these by 2, which makes them both 1. We don't have to write the ones, and that's where you get CuO. Okay? So the big thing to note is that if you have Roman numerals, it means it's a stock system. If you have a metal or a cation that falls in the transition metals in the middle here, and you look it up and it has more than one charge, you have to use the stock system. Am I worried about how or if you know how to use them? No, but I'd like you to recognize when it comes up. Okay? So, what says watch out for compounds that have been reduced? Well, we just did that. Okay, turn the page. Another type of bond, ionic bond, uses polyatomic ions. Okay, and you're like, this is sounding very crazy. Don't worry, it's not that bad. Okay, so polyatomic ions is a group of atoms held together by covalent bonds. And you're like, Miss Labiuk, you just said we're doing ionic bonds? Yes, we are, okay? But polyatomic ions, which you'll see right away, they're all made up of nonmetals, and nonmetals, we know, make covalent bonds, okay? So you can tell when a compound has a polyatomic ion as there are more than 2 elements in the formula, or more than 2 capital letters. That's the trick, okay? Each polyatomic ion, which is the group of atoms, has a charge specific to the polyatomic ion. Okay, now note, it's important to remember that the charge on the polyatomic ion refers to all of the atoms that make up that ion together. Okay, they act as one thing. Okay, so for example, hydroxide, OH, has a charge of -1. That -1 applies to the O and the H together. Okay, so for the hydroxide ion, OH negative, the negative charge applies to both the oxygen and hydrogen atoms as a group, not separately. Okay, so take a look at the next page because it lists all the polyatomic ions you might possibly come across. Okay, now first notice that they're often written with the brackets around them. That's one key that you have a polyatomic ion, and then it shows the charge written just beside it. So here ammonium is +1, but all the rest of them, they're all anions. -2, -3, -1, -3, -2, -2, -1, -1. Okay, and then here's another list here that helps you find the polyatomic ions as well. So we're going to take a look at the next page, and I'm going to show you what I mean. Okay. Okay, activity 5 in your booklet has all these different compounds and then the names down below. Okay, so what I'd like us to do is to figure out which ones use polyatomic ions and which ones use the stock system. Okay, so first thing I would do here is take a look and count how many capital letters we have. We have 1, 2, 3. And because we have 3, which is more than 2, it means we have a polyatomic ion. Okay, which means we have a group of ions. And which one is it? Well, let's see. Look at that, NH4, NH4. Okay, so our polyatomic ion is this first part here. Okay, and why is it in a bracket? Well, sometimes they don't put them in brackets if there's just one of them. That's okay. So let's take a look here. FeNO3, well, look at, there's brackets. That means there is a polyatomic ion. Okay, right on. So that's what I'd like you to do as you go through here. Okay, and take a look. So does it have more than 2 capital letters, or does it use brackets? If it also uses brackets, it's a polyatomic ion. Okay, or there's a polyatomic ion in it. The next thing I want us to find is which ones have the stock system. Okay, oh sorry, let's just keep on going. So number 3, TiBr, 1 capital, 2 capitals, no polyatomic ion. Capital C, capital P, only 2, capital S, only 2, capital G, capital A, only 2. Look at this. Capital P, capital S, capital O, and there's brackets. So this is a polyatomic ion. And the same thing would be for 8, 9, and 10, because look, they all have brackets. Okay. Okay, so that's how we can tell if it's a polyatomic ion when it's the name. And if we want to take a look down below and figure out from the name if it's a polyatomic ion, well, then all you have to do is take the names that are listed here and compare them to what you see here. Okay, and one trick is that polyatomic ions often end in ITE or ATE. Okay, that's one clue. Okay, so you can take a look and compare it. So here I see ATE. That's definitely a polyatomic ion. Okay, if I look, here's carbonate, ATE. That's going to be a polyatomic ion. And if you're unsure, just compare the name to the names that you see on the page before, because this lists all the polyatomic ions by their names. Okay. Okay, stock system. How can we tell the stock system? Okay, well, if we're looking at the formula, well, we take a look at the cation first, and we see if it falls on Professor Mokur's periodic table if it has more than 1 charge. Okay, so N, that's nitrogen. Well, we know that's a nonmetal, so that's not going to be 1. Fe, there's iron, and it has 2 charges. Okay, so this would also use the stock system. Okay, TiBr. Where is Ti? No, that's Tl. Ti over here. It just has 1 charge, no stock system. Okay. Cu, copper. Okay, has 2 charges, so that would be the stock system. Sn, 2 charges, stock system. Okay. Ga, here we go. Nope, only 1 charge. Okay, not the stock system. Okay. Pb, which is lead, right here. 2 charges, stock system. Okay. Be, beryllium, well, that's over here. That's a alkaline earth metal, so no, it's not a stock system. Mn, which is manganese. Here's manganese, stock system. Okay. And aluminum. Aluminum's right here. It only has 1 charge, no stock system. Okay, so that's how we can figure it out by using the name to figure out if it has a stock system or not. And how do we figure it out if we're looking at the name and we want to figure out the formula? Okay, well, we would take a look. Anything that has a Roman numerals has a stock system. Okay, so Roman numeral 6, stock system. Roman numeral 5, stock system. Another Roman numerals, that's 2. Roman numeral 3, Roman numeral 2, Roman numeral 5, Roman numeral 3. No Roman numerals. Lead 2, Roman numerals, no Roman numerals. Okay, and that's it. Okay. Okay, and that's it for this page. That's it. So what I would like you to do now is to go to this next page where it says covalent and ionic naming review. And I want you to use what you've learned about how to name ionic compounds and covalent compounds and fill out this practice page. Okay, and I will post the answers. Some of them just say identify which one uses the stock system and which one uses polyatomic ions, or neither. Some of them ask you for the names and some ask you for the formulas. Okay, right on. You can do it. Awesome.